lack of time, I am going to give some discussion on that means relation, and also proposition, and also the probability. That is each topic I will give only one example. You can prepare yourself. If you are having any doubt, you can mail me after completion of session. Okay. Thank you. Now I'm going to proceed.
One moment, sir.
Yes.
Once it's ready, please. Oh, okay. You can start the session, sir.
Is screen visible?
Yes, sir.
Yes. Consider the following statements: A, false assertion true. B, if alpha assertion B, beta and gamma, then alpha assertion beta and alpha assertion gamma. Which of the following is correct with respect to the above statement? Number one, both statement A and B are false. Then second one, statement A is true, B is false. Third one, A false, B true. Fourth one, both are true. In general, argument P1, P2, P3, P3, and so on, Pn, it asserts Q is given. That means that is valid. Where P1, P2, P3, and so on, Pn are premises, and Q is conclusion. So the conclusion is valid when P1 and P2 and so on, Pn implies Q is tautology. When we are applying AND operation on each proportion P1, that is P1 and P2 and P3 and so on, Pn implies Q. If the resultant of this implication is always true, then it will be tautology. Then the statement Q will be valid. That's all. So first we are going to take first statement false, that is false, conclude true. This statement is always true. We know that here left hand side is a premise, right hand side is conclusion. If premise is false, conclusion is true. We know that that means what do you mean? That the statement is always, since the conclusion is true. Conclusion is true, which means nothing but it can be whatever the value is there, either true or false, the conclusion is true. Okay. So since the conclusion is true, this statement is always true. For second statement, if alpha that conclude beta and gamma, then that alpha, which means alpha, which is the also implication. Beta and gamma, then alpha implies beta and alpha implies beta. Which means nothing but left hand side of this operator is premise, right hand side of this operator is conclusion. Right hand side conclusion. So here, close look at this. It is easy to solve if we are having few experience, some experience. So here we know that we can apply the distributive law easily. That means that alpha, I think alpha this is identical use. Alpha implies beta and gamma implies alpha implies gamma. We can take alpha implies outside of this one by applying AND operator. It easily saves that of this one. Here alpha implies beta gamma. That is implies that is it is nothing but valid operator. But the possibility I will give some. Okay. Here assertion, it also can be assertion. So implies A assertion beta and that is and will be removed by operator alpha and assertion gamma. What we need, we can take away alpha and assertion symbol by applying distribution law. By applying distributive law, we can have that alpha certain symbol taken away or validation symbol is taken away, then beta and gamma is there. So by comparing these two, it is true because they are identical. So that we can apply alpha. So we are going to apply the what means the implication formula or beta gamma, or that means P implies Q is nothing but not P or Q. So we have now what we have. So any variable, assume that it is a proposition. It is a complement of its proposition, like a digital variable. A variable, union of complement is talking about true. Similarly, here this is a proposition. The same proposition is negated here. That means R of the proposition and its negation is always true, not P or P equal to true. So that both are true. Now, consider the following English sentence. So it seems to be very much difficult for beginners to crack the examination, but it is easy after having some experience on this, how to apply the propositional logic and predicate logic. Okay, Agra and Gwalior are both in India. A student has returned a logical sentence for the above English sentence is first order logic. Sentence is first order logic, FOL, using predicate in X, Y, which means that X is in Y as far. That means the statement Agra and Gwalior are represented in Agra, India, or in Agra, Gwalior. So you can say that it is easily you can solve it. That Agra and Gwalior. That means Agra and Gwalior is the same or belongs to India. Here in Agra, this predication given in Agra, India, which means Agra in India or Gwalior in India. So that will be that is interpretation is not correct because and will be given. So we will see that one. So here it is syntactically valid, does not express meaning. Syntactically valid, that we express the meaning. Syntactically invalid, express the meaning. Invalid and does not express the meaning. So both P or Q. Agra and Gwalior are both in India. So representation in, X is means X is in Y. Here in Agra, India means Agra is in India. It is syntactically valid. In Gwalior and means Gwalior, India, it means Gwalior is in India. It is also syntactically valid. In Agra, India, or in Agra, Gwalior, India, India is syntactically valid. Syntactically valid. It is valid for P or Q. Okay. Now, in Agra, India, or in Gwalior, India is true if at least one of Agra and Gwalior is in India. Agra and Gwalior. So either Agra or Gwalior is in India, the statement becomes valid. But our condition, both are in India. So according to the English sentence, both should be true. Correct representation of the given English sentence is in Agra, India, and in Gwalior, India. So that what is our correct option? Hence option 1 is correct. That means it is syntactically valid, but does not express the meaning of the English sentence. So that option 1 is valid. Okay. Option 1 is correct. Consider the set of all possible 5-card poker hands date fairly from the standard deck of 52 cards. We know that a set of cards containing 52. That means 4 categories as that is spade, clover, diamond, and the other one heart. Okay, 4 kinds. 4 into 30, we are having 52 cards. How many atomic events are there in the joint probability distribution? So, given numbers were 25,98,960 and so on. The value is given, whatever value given, we can go to choose one of them by applying this formula. The solution in the joint probability distribution of 5 cards hand from the 52 deck of cards can be calculated as then the total number of possible combinations to have a set of 5 cards from 52 cards will be, that means 52C, that is, it is a combinatorial problem, not a permutation problem, combinatorial problem. So 52C5, NCR problem, 52C5. Now we can calculate. So the R is 10. 52 factorial divided by 55 factorial, n minus r factorial into n minus r, 52 minus 5 factorial goes to 47 factorial. Then we can apply the formula. We can expand this value. So 47 factorial, that is 1 to 47 will be cancelled numerator. The remaining 48, 59, 50, 51, 52 is remain same. Here 5 factorial 1 to up to 5. What value we have? That means this value is given. And 5 factorial 120. Now we can, the result is 25,92,960. That is one. Option 1 is right. Okay. That is a joint probability. So here, very much important, most frequently asked question is relation. So there are relation is nothing but relation is defined by using some operation. It may be addition, division, or multiplication, or some other operation by applying functions also. That means relation, we can apply any relation on given set. So the relation is given. So which means which of the relation on set here set 0, 1, 2, 3 is an equivalence relation. So the relation is said to be equivalent if it is a reflexive. The relation should be reflexive. The relation should be symmetric. The relation should be a transitive. If these three conditions hold, then we can declare, we can style, we can come to the conclusion that relation is a equivalence relation. That means reflexive, relation should be a reflexive, relation should be a symmetric, relation should be a transitive. So for option 1, 0, 0, 0, 2, 2, 0, 2, 2, 2, 3. Okay, 2, 3, 3, 2. So reflection is nothing but 0, 0. That is among 4 elements. Is mouse pointer visible?
Yes,
So
sir.
there is, okay. So reflection is nothing but 0, 0, 1, 1, 2, 2, 3, 3. When these 3 elements is available in a set, sorry, relation, that relation is reflection. Okay. So here 0, 0 available, 1, 1 is not available, 1, 1 is not available, 2, 2 is available, 3, 3 is available. So 1, 1 is not available. Since the 1, 1 is not available, it is not reflection. This is not equal to because it is neither reflection nor transitive. Missing 1, 1 for reflection. And missing that transitive is nothing but that if an element A or B, A, B belongs to relation R, then B, A belongs to R. Then only it is symmetric. But when suppose an element 2, 1 is there, what 2, 1 is there, 1, 2 also should be present in the relation. Then it is called symmetric. So here, the next example, I will give the definition because the slide is changed. Okay, here, so listen. Here, 0, 3 is the transitive is nothing but if A, B and B, C is there in the relation R, that there should be A, C should be belongs to R. You understand? A, B and B, C is there, C is belongs to R. That means A, B and B, C in relation R, then A, C should be in relation R. So here 0, 3 is not possible. Here 0, 3, 2 is available. Okay, then 2, 3 is there. So 0, that is A, B, A is 0, B is 2. Here B is 2, C is 3. Then we need A, C, 0, 3 should be present. Here 0, 3 does not present in relation 1, so that it is not transitive. So that it is not. For option 2, we know that everything is possible. That means 0, 0, 0, 1, 1, 2, 2, 3, 3 is available. It is a reflection. It is also symmetric. It is also transitive. Because when we are written, that is so, assume that 0, 0 is A, B, then B, A is nothing but 0, 0. Okay, so that's symmetric. Transitive 0, 0, and it will be repeated, reverse 0, 0, then answer 0, 0 is exists. So we can, when we are going to deal with the kind of problem, suppose any relation only contains identical pair, that is 0, 0, 1, 1, 2, 2, 3, 3 should be alone present in a relation. That relation kept in mind, that is shortcut method, kept in mind, that is satisfy the reflexive, symmetric, and transitive. So if suppose along with this four elements or four pair in the relation, some other elements there, then only we have to come to, we can calculate or we can verify the reflexivity, another one, reflexivity, okay, transitive and symmetric should be verified. Otherwise, suppose set alone contain only the similar number is there, that is 0, 0, 1, 1, 2, 2, 3, 3, A, B, B, C, C, D, 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 E only. So that relation is satisfied, fully satisfied all three conditions: reflexive, transitive, and symmetric. So it is a equivalence relation because it is reflexive, symmetric, and transitive. Just now I told you. Here, even we are found it after even we know 2 is the correct answer. So why 3 and 4 is not a equivalence? So here 0, 0 is present, 0, 1, 1 is present, 2, 2, and 3, 3 is not present. Suppose you are, first of all, it is easy to find out yourself if reflexive is if any relation does not meet reflexive or does not satisfy reflexive, you can ascertain that is not equivalence relation. You can declare it. There is no need to waste our time to find either transitive or symmetric. If one of the conditions is failed, we can declare that one. So this is not an equivalence relation because it is not a reflexive. Because 1, 1 is there, 2, 2 is not there, 3 is not there, 3, 0, 0 is available. So missing, that is when reflexive 2, 2, 3, 3 is not present. Not symmetric because 1, 2 is present, 2, 1 is not present. Okay, if A, B is blank star, B, A should be present. Okay, 2, 1, that is 2, 1 is not present. So that is not symmetric already. The previous part. Option 4, 0, 0, 0, 2. Here also 3, 3 is not present, so that it is not reflexive. Not symmetric because 2, 3 is present, 3, 2 is not present. 0, 2 present, 2, 0 not present. For transitive, 0, along the path, 0, 2 is present, then 2, 3, A, B, B, C. So AC, 2, 3 is not present. So that we started transitive. So this kind of question is very much important. At least one question in each set of question back, each question back. Option 2 is here. After following equivalence relation, sometimes function is given. This function also the relation. Here, which of the following is an equivalence relation on the set of all functions from Z to Z? Z is nothing but set of integer value. That means all integer, both positive and negative. The set enclosed. We know that Z is set of integer, Q is set of rational number, C is set of complex number, R is set of real number. Remind Z, R, Q, C. There are four set of number is divided into four categories: integer, rational, real, complex. Okay, Z is integer. So here the function 1 by 1. So here it's nothing but all integers. Z is set of integer. They have defined that means either negative or positive. A whole number. That is it. A relation on a set A is called equivalence relation if it is reflexive, symmetric, and transitive, as we have seen in the last slide. Reflexive. If A, A belongs to R for all A, that is reflexive. That be 1, 1, 2, 2, 3, 3, 4, 4, and so on. If the set of elements having 0 to 3, 0, 0, 1, 1, 2, 2, 3 should be present. Symmetry. If A, B belongs to R, then B, A belongs to A should be also available in belongs to R. But if 1, 2 is present, 2, 1 should be must be present. Cancel. If A, B, C belongs to R, then A, C belongs to R. That is transfer. So which means I think that 1, 2, 2, 3 is present, 1, 3 should be present. For 1, it is not reflection. Since okay, f of x minus g of x is the given function g of f, g such that f of x, the function f, g is defined f of x minus g of x equal to 1. So 1 is greater than 1. It is belongs to z. No problem. This type of mistake. Okay, 1 belongs to 1. Okay, so here it is not reflexive since f of x minus g of x equals 0. So reflexive is nothing but same that be A, B, C, C, D, D. Now for reflexive, f of x and g of x, when we are here, the relation subtraction is subtraction. When the same element is subtracted, so the result should be 0, but here is defined as 1, so that not reflexive. There is no need to go for any other condition. But however, I want to explain why we are saying not symmetric. It is not symmetric since if f of x minus g of x 1, that is a function 1, then g of x minus f of x equal to 1. That is symmetric. But here, when we have suppose when we are subtract g of x from f of x, it will be defined as 1. When we are subtract g of x from f of x, it goes to be minus 1. So that not equal to. So they also not symmetric, not transitive. Since f of x minus g of x 1 and g of x minus h of x 1, then h of x minus f of x minus h of x should be 2. Okay, but it is defined as 1, so that is not transitive. Then for option 2, this is not equal to here f of 0, g of 0, that is 0, or f of 1, g of 1, that is either which is nothing but identical. Okay, no problem. So that reflection is good. It is not equal to here f of 0, 0, 1. This means that meeting the equals. Now that means that any one of equals meet. That is enough. We can have that either or. We can have that f of 0, g of 0, and f of 1, g of h of 1, but f of 0 here, f of 0 and h of not h of 0, and f of 1 not h of 1, because both are identical. That is the relation is equal to this. That is f of 0 equal to that is equal to f of 0 equal to g of 0, f of 1 equal to g of 1. Then there will be a f of 1, g of 1. Okay, so f of 0 cannot be equal to h of 0, not equal to h of 0, because if these two elements, another element cannot be equal. So that because h is another element, it will be later on g of 0. That means in sequence. Okay, it's not. So that it is not transitive. Option 3, f of 0, g of 1, and f of 1, it is not a reflection. Here, just listen. So it is not equivalence relation because it is clearly neither reflection nor transitive. Neither. That means f of 0 equal to g of 1. It is not possible. F of 0 equal to here equal relation is given. F of 0 equal to g of 0. It is valid reflection. F of 1 equal to g of 1. It is reflection. But here f of 0 equal to g of 1. It is not reflection. Okay. So see that f of 0 might not be equal to g of 1. Thus the relation is not reflexive. So after any one of the condition fails, we can move to verify other relation. There is no need to wait for date for verifying other conditions. Okay. So fourth one. Here it is exact symmetric reflection because f of x minus g of x, some value, whatever you can, the value. Suppose f of 1, f of x, assume that f of x 5, value 5, minus g of x is 3, 5 minus 3, it goes to 2, 2 is missing. Okay. For example, 5 minus 5, that means it is 0. 0 is also present. That is reflection. Same value. Suppose you can assign 10 f of x 10, f of x 10 minus 10 goes to 0. It is k value, some k value. So that the k belongs to k equals 0 belongs to epsilon. Here k value. Symmetry because f of x and g of x belongs to z. Okay. So f of x minus g of x is k1 value. Suppose I assume that 5 and 7, f of x is 5, g of x is 7. So when we are subtracting 5 minus 7 minus 2, so it is also present in Z. That is k1 value. And I will give 5, 7. So g of x is 7, and this one is 9. F of x is 9. So what we have 7 minus 5, it goes to 2. So 2 is also the belongs to Z. So that it is a symmetry. So 5 to 2, 5, some values there. 5, 7, 5, minus 7, sorry, 5, 7, minus 2. So 7, 5, 2, both are present in the list of sets. So that's symmetry. Transit be f of x minus g of x k1, g of x, h of x some value k2. So then f of x minus h of x value some value. For example, apply the same value 5. I assume that 5, 7, 9 or 5, 3, 8. Whatever. Okay, so 5, 3, 5, 7, 9. Assume that 5, f of x 5, g of x 7, h of x 9. 5 minus 7, it is 2. Sorry, minus 2, it is belongs to z. So 7 minus 9 minus 2, it is also belongs to z. Here 5 minus 9, it is was minus 4, it is also belongs to z. So the fourth relation satisfies all three conditions: reflection, symmetric, transitive. So that option 4 is an equivalence relation. So it is a very much easy problem, but we can recall it. Okay. A survey has been conducted on a method of commuter travel. Each respondent was asked to check bus, train, automobile as a major method of traveling. So some survey is conducted with people, whether the people are travel with the bus, train, or automobile. Okay, more than one answer was permitted. Now only one that is the person is allowed to give more answer, more than one answer. The results report, because sometimes when raining season, traveler can use the bus or train, or other than rainy season they can use the automobile, or they can use the moped also. No problem. So here automobile, bus, train is there. Okay, here bus. So the respondent is bus 30 people, train 35 people, automobile 100 people, bus and train 15 people, bus and automobile 15, and so on. So what is this? It is easy to solve a problem, but there is no need to spend more time. So here NFA, assume that bus, that is NFA. That is, we can assume that respond is bus, that is A is a respondent bus, respect to bus response. B is nothing but respect to train response. C is an automobile response. So let A equal to N of A, that is number of people response bus, N of A equal to 30, number of response train, N of B equal to 35, number of people response automobile 600, okay, 30, 35, 100 is given. So number of people respond bus and train, A intersection, N of A intersection B equal to 15, that is given, bus and train. So bus and automobile, that is B intersection C 20 is here. Then number of people respond automobile and bus C intersection A equal to also 15. They also here 15. Train and automobile. And finally, number of people respond buses and train and automobile. That is 5 people. A enough intersection A intersection B intersection C equal to 5. Now we can apply the formula. Number of people completed the survey. N of A union B union C equal to N of A plus N of B plus N of C minus N of A intersection B, minus N of A intersection B intersection C minus N of A C intersection A intersection C, whatever it is said, plus all the N of A intersection B intersection C. Now we can put the resultant values. After applying this value, we can get 120. That is, the result is 120. A box contains 6 red balls and 4 green balls. 4 balls are selected random from the box. What is the probability? that 2 of selected balls will be the red and 2 will be the green. We are going to select 4 balls from random balls. That is will be random from the balls. The Part-1 is 6 red ball, 4 green ball. Totally, the balls contain 10 balls. So 4 plus, that is 6 plus 4, 10 balls. So among them, we are going to select the selected random. That is, the selected balls will be 2 of the selected balls will be red. The 2 will be red and 2 will be green. So what then it is easy for only, which is also the combination round. For 4 balls can be selected from 10 balls, so that 10C4. Okay, 2 among which 2 red ball can be selected from 6 red ball, so that C6C2. 2 green ball can be selected from 4 green ball, so 4C2. So what is the result? So hence the probability is nothing but the total probability, that is here 2 ball is a 2 ball that is 2 balls should be selected, 2 red balls should be selected from 6 red ball, so that 62 into 4, that is 4 green ball. Among 4 green ball, 2 green ball will be selected for balls, so 4C2, that will be multiplied. We need to multiply that value divided by total ball, that is among the total 10 ball we are getting, we are going to select 4 ball. The 4 ball may be a then 2 ball may be red, 2 ball may be a 2 ball should be red, 2 ball should be a color and green. We have 62, so we can apply the forward 6 into 5. That means I have started this one 6 factorial divided by 4 factorial into 2 factorial. Okay, that means r factorial into r minus 1, that is r n minus r factorial, which means nothing but r6 factorial divided by 4 factorial into 2 factorial. So up to 4 terms cancelled, 5 into 6 is there, plus here 2 factorial is 2. Then 4 factorial, that is 4 factorial divided by 4 minus 2, 2 factorial into r to 2 factorial. So the 1 to 2 is cancelled, 3 into 4 there, my 2 factorial is there, 2. So now what we have here, 10C4, which means nothing but 6 factorial is cancelled, that is 10 minus 4, 6 factorial here, that is 10 factorial divided by 6 factorial into 4 factorial. So up to 6 terms cancelled, 7, 8, 9, 10 is remain numerator, denominator only 4 factorial, 1, 2, 3. That is 1 into 3, 1 is, that is what no change in whenever multiplying 1. So now after reducing this formula, we can the value we can get 3 by 7. So that option 2 is second. Option 2 is here. Okay. So this question, I think, is 2019. How many solutions are there for the equation x plus y plus z equal to z to u, x plus y plus z plus u equal to 29, subject to the constraint that x greater than equal to 1, comma y greater than equal to 2, z greater than equal to 3, and u greater than equal to 0. So this kind of problem is very easy to solve. Don't get any check during the examination. It is very much easy to solve. So close look at my solution. So given x plus y plus z plus u equal to 29, and the constraint x is greater than 1, greater than equal to 1, y equal to greater than 2, z equal to greater than equal to y, u equal to greater than equal to 0. Okay. So that what is the value of this here? So x plus y plus z plus u equal to 29. So the 6 is nothing but how many minimum value? There is minimum. X can be from 1, 2 and so on. So here 2, 2 and so on. Here 3, 2 and so on. So that we can X can take the values from 1 and so 1 or more. There is more. There is x is greater than 1. Which means even x can take the values 1, 2, 3, and so on. Y can take the value. Y cannot take the value 1. It can take 2 or 3, and so on. Z can 3 or more. Y can take 0 or more. Okay. No. Now I add this constraint value That means I reduce some steps. One, you can take that means lower bound value, that 1, 2, 1 plus 2 plus 3 plus 0, it goes to 6. So the total is x plus y plus u equal 29 minus 6, we can get 23. But we can solve it. Hence, n equal 23, r equal to 4, n equal to 23, r equal to 4, we can apply the formula. The total number of solution is nothing but the formula is nothing but n plus r minus 1, c r minus 1. So please note it down. N plus r minus 1 divided by, n minus r1, c r minus 1. So here n equal to 23 and r equal to 4, 23 plus 4 minus 1, c, that is r minus 4 minus 1. Okay, 26, that means when we are calculating this value, 27 minus 26, 4 minus 1, 3, 26 C3, we can get the value. That means 26 factorial divided by 23 factorial into 3 factorial. So first numerator, first 23 terms, 1 into 2 into up to 23 will be cancelled. Below that is the denominator also having 23, since the denominator also has 23 factorial. The remaining denominator is nothing but 3 for 1, 2, 3. Then we can multiply and divide its value. We are having the value 2600. That is very good. So the formula, if you know, that is n plus r minus 1, c r minus 1. Suppose this formula can also be changed. So n plus r minus 1 instead, that is 26, 3. So n, another formula is exist for this one, and then we can check it. Instead of r, we can use m value. That is here also we can use n minus 1 value. Here also some changes available, which is also correct answer. Verify that one. Okay, I will tell you. You will discuss because some other refers different formula, but the formula is the resultant formula. The formula is, for example, 5C2 equal to 5C3. Are you clear? 5C2 equal to 5C3 because 5 factorial divided by 3 factorial equal to factorial. 5C3 means something but 5 factorial divided by 3 factorial. Okay, by applying that, the variable name. So very much important person. Okay. So partial percent is nothing partially ordered subsequence. Okay, that is first element should be less than or equal to second element should be less than or equal to third element, and so on. Okay, so the percent 3, 5, 9, 15, 24, and 45. So 3 is less than 5, 5 is less than 9, so that this is sequence order, increasing order, so that it is percent. Which of the following is correct of the percent? Percent is nothing but partially ordered set. Partially ordered set. That is percent. There exists a greatest element and least element. There exists a greatest element but not a least element. There exists a least element but not a greatest element. There does not exist a greatest element and a least element. So to do C, it is also easy problem if you are having some few experience. Okay, after having some experience, you can solve this problem easily by using the Gassy diagram. Acid diagram. So here, solution. So the given percent 3, 5, 9, 5, 15, 14, 15. So here, what is the operation on this set percent? That is a division. A divides B. 3 or B means 3 divides 5. So 5 divides B. Okay, here. So division. So the divide operation. That means A divide B means A divides B. That means B by A. You don't take B by A by B. Okay. So S equal 3, 5, 9. That is here in 4. That is a given set. Set. Relation is nothing but A comma B such that A divides B. That is the relation operation. The given set is given whatever it is. That is this percent we have it two part. One is set part. Given set. It is a relation part. So we can define the relation by applying this operator. A comma B. So A comma B such divides that A divides B. That is a relation. Such that A divides B. That is a relation. So So what are the elements here? Is among the sets, 3 can divide 9, so 3 comma 9. 3 can divide 15, so 3 comma 15. 3 can divide 24, 3 comma 24. 3 can divide 45, 3 comma 45. Then 5 can divide 15, 5 comma 15. 5 can divide 45, so 5 comma 45. 9 can divide only 45, it can. Then 15 can divide 45. Then 3 comma 3, 5 comma 5, 9 comma 9. That means itself. That means 3 by 3, 1. 5 divides 5 times. That's all it's, that is reflected. 3, 3, 5, 5, 9, 9, 15, 15, 24, 24, 45, 45. There is a total. That is all elements which is available in the defined relation. That's all. Okay. Now, let us proceed. We are going here. So first we have to draw the direct graph. So listen here. So we can draw the direct graph 3, 9. That means headed arrow should be a number should be numerator. 3 divides 9. So that similarly 3 divide 15. Okay. Then 3 divide 24. Then 3 divide 45. 3 divide 45. 5 divide 15. So close look at the headed arrow. 5 divides 15. So that the arrow goes towards the 15. Then 5, 15, 5, 45. 5 divides 45. 9 divides 45. 15 divides 45. 3 divides 45. 5 divides 45. That is itself 45. So it will not. Now you have to eliminate. Example, listen here. The Hasse diagram tells us. Suppose, as in the close occurred statement, 3, 15 is there. 3 divides 15, and 15 is divided by 15 divides 45. So that there is no direct link to 3 to 45. Which means A, comma B, comma C is there. A, comma B, comma C is there. That means there is no edge in Hasse diagram. There is no edge between A to C. That means 4 to 15. So first of all, that is the same reflexive element should be eliminated. 3, 3, 5, 5, 9, and so on. The second thing, what I told you just now, that means 3 divides 15, 15 divides 45. So A, comma B, comma is there. Then if A, comma B and B, comma C is available in direct graph, so you cannot in Hasse diagram you cannot have the link or edge from A to C. Okay, directly. So directly. We are going to move 3 to 15, 15 to 45. That's all. You could not draw the edge from 3 to 45 directly. A to C. So you can remove it. 3 to 45 will be removed. And then similarly, so 5 divide, listen, 5 divide 15, 15 also divide 45. So A, comma B, comma C, so that this term will be removed. That is no direct link or edges from 5 to 45. So that should be removed. Then another one, okay. So the remaining is there. So such element is not exist there. Now this diagram is converted to this 3 divides 50, 3 divides 9. So the 3 to 9 is okay. 9 divides 45, 3 is okay. So that will. So 3. So among these values, 3 and 5 is unrelated. That is distinguished value. So 3, 5 is a basic value. That is a distinguished value, unrelated value, because 3 cannot divide 5, 5 cannot divide. So initially we have 3, 5, and what are the numbers which is divisible by 3? 3. That means 15, 24, and 45. Because 45, the 15 also the 15 divides 45, so that this link is broken. Only this link will take. So that here draw this one 3 to 15, 15 to 41, and 3 to 24. Okay, and 3 to 9. 9 to 15. 8 to 9, that is 3 divides 9. 8 to 15, 3 divides 15, 3 also divides 40. Okay. 3 to 9, 3 to 15, 3 to 24. So 3 divides 9, 15, 20. Then 5 is there. 5 divides 15. Okay. 5. Then 9 divides 45, 15 divides 45. 9 divides 45, 15 divides 45. That's all. So edges are here not a headed arrow. That is just like the node will be represented number, not just like dot. It has uses the dot symbol. There is no circle symbol here, but we have so we can some definition is there. I will tell you. The greatest. What is the question? Which of the following is correct? The greatest. Yet there exists greatest element and a least element. These two, we are going to finding out greatest element, least element. After the finding the value, we can verify that which answer to be which option is correct. The greatest element. Let's look at the definition. The greatest element only exists if there is exactly one maximal element, and is then also equal to that maximal. So the maximal element is nothing but that means any element does not having any value in its upper location, in their upper location. So here, assume there 1 second. The maximal element is nothing but any element has a diagram does not have any value on upper. So here 24 and 45 does not have no element in or no value in upper. Okay, upper. So that these two are maximal element. So 24 and 45 are maximal element. So if only one maximal element exists in a C diagram, that element is called greatest element. According to this example, we are having two maximal elements, so that the greatest element does not exist. Greatest element does not exist. So now the next one, least element. We are going to least element. So the least element only exists. There are exactly one minimal element that is and is then also equal to that minimal element. So here minimal elements are, what are the minimal elements? But an element, any element that does not have any value below it, so that here in this graph 3 and 5 does not have any element below it, so that there are two minimal elements there. So that the least element is nothing but exactly one minimal. So according to our example, here 3 and 5 are two minimal elements there, so that least element does not exist. So that what we do? So no greatest element, no least element. So what is option? Does not exist greatest element and a least element. So that fourth one is correct. Fourth one is correct. That it does not exist greatest element, also does not exist least element. So the option 4. Okay. Please note it down. Option 4 is correct answer. No, does not exist greatest element, does not exist least element. So fourth option is correct. Next. How many bit string of length 10 either start with a 1 bit or end with a 2 bits. End with start with 1 bit. So look at this question. Let n of a is number of bit string of length 10. That's length 10 that starts with 1. That is among the 10 length of 10. That means first character should be 1. So the remaining entry is 9 character. That is there will be. So here there will be a by 0 and 1. Okay. So there will be a any value, that is 2 power 9 possible values. 2 power 9 possible. Here, goes to the example 1. So here, first character should be 1. Letter digit 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, what we need, the 9 value should be filled. What way? How many ways is there? So here, that is 1 is fixed, so the only one way, 1 enter. So this can be filled by 2 ways, either 0 or 1. So the 2 way. It can be also filled as 0 or 1. Okay. It can be also 2 way. It can be also filled 2 way, and so on. Totally 2 into 2 into 9 times, that is equal to 249. 249. Okay. Then at the end of B, put number of strings of length 10 that starts with 1, 2 power 10. Start with 1. Sorry, some mistake. That means end with 20. End with 20. So I have copy from this here, so that I will change it. So bit of length of number of string of length 10 that end with double 0. Okay, here 00. Please change this. Here, please change that end with 00. So that end with the 00, the remaining bits 8, so that it can be filled 2 ways. It can be filled 2 ways. Third element, the third number can be filled 2 ways. So that total 2 power 8. So these 2 are fixed. That is 1 way. So that 2 power 8. So we know that n of a is given, n of b is given. So we can exclude that this inclusive exclusive principle is mathematics exists. Inclusive exclusive. So it is only string 2 power 9, 2 power end. Start with 1, end with 2. Suppose some string can start with 1, end with 00. That could be subtracted, excluded from the list. That is inclusive exclusive. So the string is start with 1, this string is end with 1, number of end with 00. But some string can start with 1 and end with 00, because they given either start with 1 bit and or end with 2 bits. So suppose any string start with 1 and end with 00, that is not allowed. Excluding that, so that inclusive. So that we need to find out n of a intersect n of b. N of a intersect n of b is number of bits of 10 that starts with 1 and end with 00. Okay. So the 3 position is fixed. That in first position is first position will be 1, last position 9 and 10th position 3. The remaining 7 position will be 2 power 7. That is first start with 1, end with 00. So that this is fixed. Only 1 way there. Remaining are 2. Okay. So that 2 power 7. So now we can conclude that what we need n of a union b equal to n of a plus n of b minus n of a intersection b. What when number of bits string of length 10 that start with 1 or end with 0, n of a union b equal to n of a plus n of b minus n of a intersection b. 2 power 9 plus 2 power 8 minus 2 power 7. What is the value? 2 power 9 plus 2 power 8 minus 2 power 7 equal to, we can take away from 2 power 7 as common. So remaining 2 power 9, remaining available 2 power 9, 2 power 2, that is 4. The 2 power 8, 2 power 7 is taken away. Only 2 power 1 is there, that is 2. 2 power 7 is taken away, that will be 1. That 1 into 27, 2 power 7. That will be 2 into 2 power 7, 2 power 8. 2 into 2 power 9, sorry, 4 into 2 power 9 is 2 power 2, 9 into 2 power 2, that is, sorry, 2 power 7 into 2 power 2 equals to 2. Very started. So anyway, you can solve it. Either you can, or you can expand the full value. 2 power 9 plus 2 power 8 minus 2 power 7. Also kind. So 2 power 5 is 32, 5 is 32, 6 is 34, 7 is 128, 8 is 256, 5 12. We can apply the value, we can get it. So 128 into 5, it was 640. That is answer 3 is suppose that a connected planar graph has a connected, that is a connected planar graph has 6 vertices, and each that is each of degree of 4 into how many regions in the plan divided by planar capacities of this graph. So Euler gave a formula which connects the number of vertices V, number of edges E, number of regions R. The connected planar graph or map can have V minus V plus R equal to 2. From this formula, we can derive R equal to E minus V plus 2. It is given. Euler defined a formula. There is a map contains V vertices and E edges and R region. Then V minus C plus R equal to 2. So we are going to finding out. Planar number of planar. It's a region. Sorry, number of regions R. So the R equal to V. R equal to E minus V plus 2. The given formula is rewritten. So the sum of the degree of the regions of map record twice the number of edges. That is one. So the handshaking theorem says that number of the regions equal to twice the number of, that is number of degree of map, number of degrees of regions of map, number of degrees, not region, number of degrees of regions, 2e. Or it is also equal to number of vertices, degrees of number of degrees of vertices, the sum of degrees of vertices equal to 2e. That is also handshaking theorem. Okay, the sum of degrees of vertices equal to 2e. Sum of degrees of regions of a planar graph map is equal to 2e. That is it. So here, since each vertex, we know that there are 6 vertices there, each are having equal vertex, each of degree 4. So 6 into 4, totally we are have 24 degrees. Each of vertex has degree 4. The sum of degrees, simple logic, sum of degrees of vertex equal to 2e. So sum of degrees of regions is equal to 2e. That's all. Both are handshaking. Okay, 6 into 4 into 2, 4, 24. So that which is equal to 2e. Okay, which is equal to 2e equal to 24. So E equal to 12. Equal to, thus we have B equal to 6. Then E equal to 12. That means E equal to 24 by 12. And R equal to, we can apply the formula R equal to what? E. 12 minus 6 plus 2, we can get E. So 8 is answer, which is 2 is option. Let's look at this. A. I have A, B. An example, it is used to understand this concept. So here 6 vertex, that is from A it has 4 degrees, A to B, B to D, A to E, and A to M, 4 degrees. So B can have also 4 degrees, B to A, B to C, B to D, and B to E, 4 degrees. C already having C to B, then C to 2, 3, 4 degrees. D already having D to E, D to A, D to C, D to B. Okay, then one more, 4 degrees. F equal to also have 4 degrees. F to A, F to B, F to C, F to E. That is each, there are 6 vertices, there A, B, C, D, E, F. All each edge is having a degree 4, that could be represented. Planar. So that the planar graph is nothing but an edge, any edge does not cross, that a plan is drawn without crossing any edge. That means no edges cross each other. So A to B, I have drawn. A to B, that one I have drawn. Then A to E, then A to E, then A to B already. So that now we can start B to C, B to D, B to E, C to D, and C to F. There will be B to 4, that is B to A, B to F, B to C, 3, B to D, 4. Now C already having 3, another one, C to E. Then D to C, D to E, then already D to A, D to B, D to C, D to E. 4, okay. Then E, from E, you can have already C to the E to F1, E to C1, E to we are ready. 1, 2, 3, 4. Now F also already, because when we are trying E, already A to E, C to E, then we can E to F, D, E to F. Now F having edges A to E to sorry F to A, F to B, F to C, and F. So that E, that is
Hello, sir. Sir, it has been stuck, sir. Sir.
Thank you, sir. It was really a wonderful event. Now I request our organizer, ma'am, Dr. T. N. Aruna, to propose the vote of thanks.
Good evening to all. On behalf of the Principal and Department of Computer Science, it's my privilege to propose a vote of thanks on this wonderful occasion. I express my sincere gratitude to the distinguished speaker, Professor T. Krishna Kumar, for enlightening us with his commendable speech on the subject discrete structures and for making this 5 days FDP an unforgettable event. Thank you, sir. And my grateful thanks to the head in charge, faculty members, students forum, and last but not least, the participants for the everlasting support for this organizing this event. Thank you all. Thank you all for the participants.
Thank you, ma'am.
Thank you, sir.
Dear participants, you can
always
find the link for your attendance as well as
Sir,
e
thank you,
certificates in the
sir.
comment section now.
Krishna Kumar, sir. Thank
okay,
you
madam.
a lot.
Thank you. No problem.
Thanks for your
Always
acceptance for such a long duration of 5 days, sir. And due to time constraints, we have been forcing you to stop some of the topics. So definitely we'll be having some more sessions, sir. Anyhow, thanks a lot for your acceptance, sir.
I would like to something about say this the organization of this department. That means even it is crucial time, that is COVID-19. So that effort will be taken, group of people, including HOD, principals, and organizers, and student forum also. I thank all the organizing committee and head of the institution, head of the department, and organizer, and gave me an opportunity to share my knowledge of like scholar, professors, assistant professor, associate professor, and PG students. Thank you very much for given opportunity to share my knowledge and thoughts to our students. Thank you.
Thank you, sir.
Thank you.
Dear participants, kindly fill both the links. Thank you.